This is a lesson on quadratic functions, particularly in vertex form. Before we learn about quadratic functions, we must first be sure we know what an actual function is. A function is the relationship between the inputs of an equation and its outputs. For a relationship to be considered a function, it must never have more than one output for each input. The inputs and outputs are usually represented with the variables y and x. X represents the inputs and y represents the outputs. A quadratic function is a type of function in which the equation squares x. A quadratic function usually has two forms that it's found in: standard form and vertex form. This lesson will specifically be about vertex form, which is y equals a parentheses x minus h parentheses squared plus k. Because x is squared in the equation, when the equation is graphed, it makes a U shape. This is called a parabola, as you can see here. Parabolas are often found in everyday life. For example, in this first picture of two kids throwing a ball back and forth, the path the ball makes between them is a parabola. So is the path the water creates from a drinking fountain, as well as the path of a child being pushed on a swing. Also, the famous McDonald's logo contains two parabolas as well. Going back to vertex form, the equation used for quadratic functions, each variable in the equation represents a different way that the parabola can be altered. Let's begin with a. The a variable affects whether the parabola opens upward or downward. If the a variable is negative, the parabola will be flipped upside down and open downwards. If the a variable is positive, the parabola will open upwards. A also affects how skinny or wide the parabola will be. If the a variable is between 1 and negative 1, the parabola will be wider. If the a variable is larger than 1 or smaller than negative 1, the parabola will be skinnier. So the larger the absolute value is of the a variable, the skinnier it will be. And the smaller the absolute value of your a variable is, the wider your parabola will be. The next variables that affect what your quadratic function will look like are h and k. H and k affect where on the graph the parabola is located. The vertex of a parabola is the highest or lowest point on the parabola. It's also where the symmetry line hits the parabola. The point of the vertex is actually located at hk. The larger the variable h is, the farther to the right on the x-axis the parabola will be. The larger the variable k is, the higher on the y-axis it will be. So h affects where the parabola is located on the x-axis, and k represents where the parabola is on the y-axis. You can learn more about a function by looking at the four faces of a function, or growth. Growth stands for graph, rule, words, and table. Rule is the equation of your quadratic function, and words is the problem. Let's begin with words. An example problem is two kids are playing catch 8 feet away from each other. The ball reaches the height of a 9-foot tree they are standing by. What is the equation of the path the ball takes traveling from the first kid to the second kid? So from this problem, you can pick out the important information: that the kids are standing 8 feet away from each other and the ball reaches a height of 9 feet. Remember that the highest point on a parabola is the exact middle of the parabola. If you know it is the exact middle of the parabola, and you know that the parabola stretches 8 feet, you now know that the center of the parabola is at 4 feet. This means that the vertex is 4, 9, and the h of the equation is 4, and the k of the equation is 9. As we move on to rule, you can plug the information that you know into the equation to make y equals a parentheses x minus 4 parentheses squared plus 9. For finding the exact equation of the path the ball takes, you will need to find a. For now, you can replace x and y with 0, 0, because you know the graph hits that at some point. What you will end up with is 0 equals a parentheses 0 minus 4 parentheses squared plus 9. If you subtract 9 from both sides and attempt to get a alone, you will get negative 9 equals a parentheses negative 4 parentheses squared. After squaring negative 4, you will get negative 9 equals 16a. You are still continuing to try and get a by itself to figure out what the a variable is, so you divide both sides by 16. This will bring you to the answer negative 0.56 equals a. If you plug that into your equation, you will get the exact equation, which is y equals negative 0.56 parentheses x minus 4 parentheses squared plus 9. By looking at this equation, you can tell that the vertex is 4, 9, because h is 4 and k is 9, which means that the vertex is located 4 points to the right and 9 points up from 0, 0, or the origin. You can also tell that it will open downwards because a is negative. Since a is between -1 and 1, the parabola will be wide. If you still don't know how to graph it after this equation, create an xy table. As I said before, x stands for the inputs and y stands for the outputs. Write the numbers you will use for inputs on the x side of the table. Solve your equations to find y, or the output, by substituting each of your inputs for x. Write your answers on the y side of the table with its corresponding input. All of these will be points on the graph. For example, when you substitute x for 1, the answer you will get is 4, and 1, 4 will become a point on your graph. Next, you can connect the dots to find what your parabola will look like. As we move on to our graphs portion, we can graph our vertex point, which we have discovered to be 4, 9. Once you locate the x-intercepts, which are 0, 0, and 8, 0, because the kids are standing 8 feet away from each other, you can connect the points you know with a curve to find your final parabola.